Hello everyone, welcome back to my channel Saisha. This is Amok Kalwa. If you are new to my channel, please like, share, comment and subscribe my channel and press the bell icon for the latest updates. In the last video, we understood about ROC curves. We recalled few of the concepts of specificity and sensitivity which are used in building ROC curve. And we also understood how to implement ROC curves using an example. In today's video, we will be understanding about k-fold cross-validation technique. How to build k-fold cross-validation technique using some procedures. Implement k-fold cross-validation technique with an example. And also understand about different variations of k-fold cross-validation technique. K-fold cross-validation. It is a technique where a given data set is split into k number of sections and each section is used as a testing set at some point of the time. Let us understand the k-fold cross-validation technique using diagrammatical representation. We have a data set. Initially, we will randomly shuffle this data set. After shuffling the data, we create folds. As we have considered k is equal to 5, that means we are going to create 5 number of folds. So we have split the data into fold 1, 2, 3, 4 and 5. Now we are considering one fold as the test set. In the step 1, we have considered fold 5 as the test set and fold 1, 2, 3, 4 as the training set. We build the model on the training set and we test it on the test set. After building the model and testing, we record the results in data frames. After recording the results, we discard the model. Similarly, in step 2, we have considered fold 1 as test set and fold 2, 3, 4 and 5 as training set. This goes on until all the folds are utilized as the test set. This is how a k-fold cross-validation technique works. Now let us understand different variations of k-fold cross-validation. We have different variations of cross-validation. In this scenario, we are understanding 5 types of variations. In the first variation, we have train and test split. This is the variation which is widely used in the industry, wherein you split the data into train and test by choosing randomly. The second variation is leave one out cross-validation. Consider you have 6 number of observations. In that, you leave one observation as a test set and consider the others as 1 to 5 as your training set. You repeat these combinations until you have taken or chosen all the observation as a test set. Here, the time complexity for applying the leave one out cross-validation is NC1, that is n number of combinations. As you increase the number of combinations, the time complexity increases. Leave P out cross-validation. Here, consider if you have 5 observations and you take P as 2, which means 2 observations are chosen as test set. In this case, we have chosen 4 and 5 as a test case and the rest 1, 2, 3 as a training case. You repeat these until all the observations of combination of 2 is considered as your test set. Here the time complexity is very huge. For example, if you have 100 observations and 30 are considered as your leave P out cross-validation observation, then the combinations would be 3 into 10 raised to 25, which is huge. Hence, this leave P out cross validation is not widely used. Stratified type of cross validation. In this type of variation, you choose same proportion of observations as target variable. For example, if you have 60 to 40 ratio of healthy to bankrupt companies, then each of the folds has same ratio of healthy to bankrupt companies. Repeated type of variation. In repeated type of variation, you repeat the cross validation for certain number of times. Here we randomly shuffle the data before each of the repetitions. These were few of the variations of cross validation. Now let us understand the cross validation with an example. Example on K-fold cross validation. We have a data set of 6 observations and we are considering folds as 3. Before we are creating co-folds, we are randomly shuffling our data. And we have created 3 folds. In fold 1, we have values 5 and 2. Fold 2, values 1 and 3. And in fold 3, we have values 4 and 6. After building the folds, we create 3 models in which we are considering fold 1 and fold 2 as a train set and fold 3 as a test set. That is 5, 2, 1 and 3 as our train data, 4, 6 as our test data. Similarly, we are building model 2 where we are considering fold 2 and fold 3 as our train set and fold 1 as our test set. In model 3, we have considered fold 1 and fold 3 as our train set and fold 2 as our test set. For each of the models, we record the results of train error and test error. And depending on the performance of different models, we choose the model for further processing. This is how a K-fold cross validation technique works. If you like my video, please like, share, comment and subscribe my channel and press the bell icon for the latest updates. Thank you.